Hello everyone, today we learn about glycosaminoglycans. So these are heteropolysaccharides and these are extracellular polysaccharides which are present in the animal extracellular matrix of the animal cells. So before talking about glycosaminoglycans, we'll learn what is an extracellular matrix. The extracellular matrix means there is a matrix which is present outside the cells because animal cells do not have any cell wall, so the rigidity and the shock absorbance power is provided by an extracellular matrix. So this extracellular matrix, first of all, it is also known as the ground substance, also known as ground substance. It holds two cells together. It is present in only in animal cells, and it holds cells together and provide porous pathway for the diffusion of oxygen and nutrients. What is the biochemical nature of ECM? So ECM is composed of an interlocking meshwork, and this meshwork is formed by a meshwork of mesh heteropolysaccharide and fibrous proteins. Fibrous proteins. These fibrous proteins, such as collagen, elastin, fibronectin, and laminin. This forms a viscous jelly-like material around the animal cells and provide a way for exchange of nutrients and oxygen and other gases, and it also provides a shock absorbance power for protecting the animal cells. Now, let's talk about if we talk about glycosaminoglycans. So, glyco, as the name suggests, so there are two things. There are glycans, means they are polysaccharides, and amino. So there is an amino part. These are amino part. So mm, these these are heteropolysaccharide. First of all, heteropolysaccharide means composed of more than one monosaccharide. And these heteropolysaccharide, they are negatively charged and they are linear or the unbranched polymer. Linear, or we can say unbranched. They mostly exist as proteoglycan. They glycosaminoglycans, they exist as proteoglycans, which means that there are two components, protein and the glycans. In this, the glycan part, the polysaccharide part, it has higher proportion. This polysaccharide part has higher proportion, and this protein part has low proportion. So these glycosaminoglycan, they exist as proteoglycan, but there is an exception over here. Exception: hyaluronic acid. Hyaluronic acid. So this it exists as an glycosaminoglycan only and not as protein glycan. If we talk about the shelf life of glycosaminoglycans, the half life is usually less than 7 days. But keratin sulfate, keratin sulfate have a half-life of nearly 120 days, which is an exception. Now the next, if we talk about its structure, like glycosaminoglycan, as we told, it is a linear polymer. So it is a heteropolysaccharide. Heteropolysaccharide means um, mm, there are different polymers. So heteropolysaccharide, it is composed of a repeating disaccharide. Repeating disaccharide, and the repeating disaccharide is one is there are two sugars. One is an acidic sugar and other is an amino sugar. This amino sugar is either glucanac, glucanac or galnac. Glucanac means N-acetyl glucosamine, or galnac means N-acetyl glucosamine. So this is an amino sugar which is acetylated, and this is either the derivative of glucose or gal, and this amino sugar is usually sulfated. There is sulfur group present, so this is usually sulfated at different OH groups. And OH groups. So this sulfate group SO3, so this will provide negative charge. So acidic sugar is also negative charge, and this will impart more negative charge. And there is again a exception, hyaluronic acid. It does not contain the sulfate group. Hyaluronic acid does not contain this sulfur group, this sulfate group, but it is still, you say, it is written as hyaluronic acid. So it means it is acidic in nature. So it is due to the uronic group. It is due to the acidic sugar that it has a negative charge. Now acidic sugar, it is either glucouronic acid or ioduronic acid. Ioduronic acid. So iuronic acid, so it means there is a COH group. The OH group is oxidized to COH, and this is why this is an acidic sugar, and it is also an exception over here, keratin sulfate. Keratin sulfate, it does not contain acidic sugar, it just contains galactose instead of the acidic sugar. So galactose is an exception. So keratin sulfate is an exception over here. It does not contain acidic sugar, but it has sulfate group, so it has negative charge. Now because all these have negative charge, either due to the acidic sugar, they are negatively charged. They're linear polymer. They have negative charge either due to acidic sugar or due to the sulfate group, sulfate group of the amino sugar. So Due to this negative charge, there will be repulsive force. The negative groups will repel each other. There will be repulsive force. So to avoid this repulsive force, or to minimize the repulsive forces among these negatively charged group, then these glycosaminoglycans, they they attain a extended conformation. Extended conformation. Conformation. Which means like this, they are like extended. They are not condensed form. They are like extended from the cell surface, away from the cell surface, like this. It is to avoid the neighboring charge, and it is due to avoid the negative charge, repulsive force of the due to the negative charge. Now we'll take some examples of the uh, glycosaminoglycans. The examples are halonuric acid. First example, let's say halonuric acid. Halonuric acid, first of all, it gives gel-like appearance. It is the simplest glycosaminoglycan. So all glycosaminoglycans actually, glycosaminoglycans, because they are high molecular weight, and uh, because of their high molecular weight, and high water retention capacity, they give gel-like appearance. So now we'll take some example. Halonuric acid, it is the simplest glycosaminoglycans, and with up to the molecular weight is, they have nearly 50,000 repeating units. 50,000 repeating units. So repeating unit over here is a disaccharide, and it is so that's why the molecular weight is quite high. It is more than 1 million. And due to this property, they serve as lubricant. They serve as lubricant in the synovial fluid. Synovial fluid. It is also an important component of ECM of cartilage and tendon. Cartilage and tendons. It gives the vitreous humor which is present in the eye. So in eye, behind the lens, the vitreous humor is present. So in the vitreous humor, it gives jelly-like content. In vitreous humor, it gives jelly-like consistency. It gives jelly-like consistency to the vitreous humor. Now it forms a clear, highly viscous solution. It forms a clear, highly, due to this high molecular weight, it forms a highly viscous solution. So in hyaluronic acid, as we have seen, as I've already told you, hyaluronic acid, it exists first of all as glycosaminoglycans only, and it does not exist as proteoglycan, as in the case with the other glycosaminoglycans. And the other exception is that it is not esterified with the sulfate group. It is not. So hyaluronic acid is not esterified with sulfate group. Now the next glycosaminoglycan, next example is chondroin sulfate. So as the name suggests, it has a sulfate group, so it means that the amino sugar has a sulfate group. Uh, in Greek, in Greek, chondros means cartilage. So this chondroitin sulfate is majorly present in cartilage, tendons, ligament, and the walls of the aorta. And the repeating unit, the number of repeating disaccharide unit, repeating disaccharide unit, the number of repeating disaccharide unit is usually between 20 to 60 unit, and it exists as proteoglycans. Next is dermatan sulfate. This was second example. Third example of glycosaminoglycans is dermatan sulfate. Dermatan sulfate. So as the name suggests, it has sulfate group. Then amino sugar is sulfated. The amino sugar has sulfate group, and derma means skin. Derma means skin. So it means that it is present in skin. It is also present in blood vessels, and heart wall. Next is the next example of glycosaminoglycan is keratin sulfate. So it has no uronic acid, and the sulfate content of the sugar, sulfate content is also low. Where it is present? It is present in cornea, cartilage, bone, and a variety of horny and dead structures. Horny horny structure. Okay, it is found a horny structure formed by dead cells, like nails, hair, hooves, horn, claws. They all contain the keratin sulfate. And the number of, excuse me, repeating number of repeating disaccharide unit is nearly 25 over here. The next is example is an heparin. Heparin, we all know that it is a natural anticoagulant. Anticoagulant which prevent the blood clotting, and it is made in mast cells. So the number of repeating disaccharide unit here is between 15 to 90. So this was all about glycosaminoglycan, and if you have any doubt you can mention in the comment section, and you can even suggest if you want any video on any own topic. You can suggest the topic you want to lecture on. And thank you for watching my video. I request you to subscribe if you haven't subscribed yet, and please do share it with your batchmates, friends, or those if there's someone is a says a net aspirant, so uh, to whomever it can help. So please share it with those people. Thank you so much.